Today we're going to talk about arc length and area of a sector. Yes. Are they out? It's in there somewhere. Not that. No, not that one. Yeah. Well, this was an old Algebra 2 assignment that I stole. Yeah. No. Okay. So, that didn't work. Imagine you have a pizza. Pizza. Because I didn't bring one. Okay. So, let's say we have a... Oh boy, that's pathetic. A slice of pizza, and we'll say that the angle is like 50 degrees. The crust of that piece of pizza is called an arc. An arc is a portion of a circle. So that could be an arc. That is not an arc because there's no circle that fits. So an arc, by definition, is part of a circle. So let's say that this particular piece of pizza is 16 inches, so the radius is 8 inches. Now, that's your piece of pizza. My piece of pizza is this one, which has a 310 degree angle. So we each get one piece. I think that's fair. No? You don't like that? So your piece of pizza has an arc. It's the crust, and that would be called a minor arc because it's less than half. My crust would be called a major arc. And then if you were to cut a pizza exactly in half, both of those are called semicircles. Okay? And our job for today is to figure out a way how to calculate arc length when you're given the radius and the angle. So we'll do this in degrees first, and then we'll decide we don't like it, and we'll do the same thing in radians, and we'll decide we like it a lot. No. I'm not that nice. Okay. So I know the radius is 8 inches, and I know that the central angle for your slice of pizza is 50 degrees. How are we going to calculate the crust length of your pizza? Math stuff, good. Can you be more specific? Arc length, right. Oh, good. So the circumference of this pizza, C, equals 2 pi times 8. So the circumference of this pizza is 16 pi inches. What is that? I have a calculator somewhere. So 16 times pi. So the total circumference is 50.27 inches. Okay? Now what? Okay? Let's type in 360 divided by 50, and I get 720%. Now that doesn't make any sense. How about 50 over 360? How about part divided by whole? That's how we get a percentage. So 50 over 360 is 13.9%. So your slice is 13.9% of the entire pizza. Now what do I do? Multiply these two together. So I'm going to times this by 50.27. So the crust length of your pizza is 6.98 inches. Okay? So mine would be 50.27 minus 6.98. Okay? Well, let me show you how we could set this up. So arc length, for some reason, the variable that we choose is s. I don't know why. So we could create the arc length by doing this. We find the circumference, which is 2 times pi times 8, and I multiply that by the percentage, and the percentage was found by doing 50 over 360. And that's what gave me the 6 point whatever inches. Okay? Let's try to do the same thing in radians. Okay? And remember, we defined radians in terms of arc length, not in terms of rotation. So we said, if your radius is 1, then the arc length for any angle, the crust length on any piece of pizza, is equal to the angle of that piece of pizza in radians, not in degrees. So first we need to convert this 50 into radians. How do we do that? Times it by pi over 180. The zeros cancel out. So that central angle is 5 pi over 18. If the radius was 1, how long is the crust? 5 pi over 18. So if your radius is 1 unit, then your crust is equal to the angle. That's why we made radians the way we did. Well, what's the difference between those two pizzas? Well, the angles are the same, right? Both of these angles are 5 pi over 18, but what's the difference? The bigger pizza is 8 times bigger than the small pizza. So to find the arc length of the bigger pizza, all we need to do is times the arc length of the smaller pizza by 8. And just so you know, anytime you have two similar objects, all one-dimensional lengths are proportional. Okay, so any measure in inches over here is proportional to any measure in inches over there. The two-dimensional objects are also proportional, but they're different proportions. The areas are proportional, but it's actually 64 times bigger. It's 8 squared bigger. If you were to make volumes, they would be proportional, but it would be 8 to the third times bigger. Does that make any sense at all? Maybe, maybe not. So, to find the arc length, I'm going to take my angle, and I'm going to times it by 8, and that turns into a 9, and that turns into a 4. So 20 pi over 9 inches. This is the exact answer, which sometimes is really useful. But I don't know my inches in terms of pi, so whenever you calculate arc length, you need to give two answers. You need to give the exact answer and then the decimal. So 20 pi divided by 9, which is 6.98 inches. Yes. The radius of the small one is 1, and the radius of the big one is 8. So the radius is 8 times bigger, which means the circumference is 8 times bigger. So the formula for the arc length is really easy. S equals excuse me. I almost died. So if your angle is in radians, all you have to do is take the radian measure and multiply it by the radius, and that will give you the arc length. And then the arc length needs to be given in two versions. So this is the exact answer, and that's the approximate decimal answer. Okay. Well, what if I had a 50-degree angle? There's got to be a better way to solve that than that big nasty equation that we came up with. Well, one really easy way would be convert to radians and then times by the radius, right? So we would take 50, we would times it by pi over 180. And then we multiply that by 8. And that would work, correct? Well, look at this top equation. Let's just move some things around. Let's move the 2 and the pi over here. And let's move the 50 in front of there. And I get 50 times, well, we'll move the 8 to the other side, times 2 pi over 360 times 8. Well, 2 pi over 360 is also pi over 180. And notice, those are the same. Well, when we found the percentage, we took the 50-degree angle, and then, yeah, turn the 50 to radians, and then multiply it by the radius, is exactly the same thing as finding the circumference of the circle, and then turning that 50-degree angle into a percentage. So really, all we did at the beginning was convert to radians, and then multiply by the radius. They accomplish exactly the same thing. So we never ever find arc length in degrees. It just takes way too much time. So on your paper right here, we have a 90-degree angle and a 6-foot radius. Well, we don't want to use 90 degrees. We want to use the radians. So S equals 6 pi over 2, which simplifies to be 3 pi feet. Okay, that's the exact answer. You also need to give the decimal answer. 3 times pi is 9.42 feet. So arc length is incredibly easy if you have radians. In degrees, arc length is kind of a mess. Okay? Well, let's go back to our pizza. So 50-degree angle. The area of the slice of pizza is called the area of a sector. A slice of pizza is called a sector in geometry. It has an arc length, and the center of the kind of the pointy end on the pizza is in the center of the circle. So how would I find the area? Well, right, pi r squared, and I know that my slice is 13.9%. So let's find the area of the whole pizza and times it by 13.9. So pi times 8 squared times 13.9%. So pi times 8 squared times 0.13, it was 0.13888, wasn't it? Oh, what did I do? Oh. And then I need a pi also. Does that seem right? No. Not 18 squared. Oops. I'll figure this out eventually. There we go. So your particular slice of pizza is 27.925 square inches. Don't know. This was a low fat pizza. I'm just teaching you how to find area of a sector. Well, so you've seen the pivots around, the big sprinkler pivots on the farms. Not all of them are a full circle, right? Most of them are not. So if you have a pivot that looks like this, you could find the acreage inside that pivot will water. So Well, but a pivot, but if you drew a square around that, you're missing. We broke my calculator. Okay, so to find the area, well, let's do a radian measure because it's a lot easier in radians. Okay, so in radians, we're going to take, what was this, 5 pi over 18, and my radius was 8 inches. So pi times 8 squared times the percentage, which is 13.8%. But in radians, it would be 5 pi over 18 divided by the whole pizza, which is 2 pi. 2 pi over 1. So in degrees, it's 50 over 360. In radians, it's 5 pi over 18 divided by 2 pi over 1. So if I invert this, 1 over 2 pi, pi cancels pi. So I get 5 over 18 with a 2 in the denominator. See that? I get 5/18 with a 2 in the denominator. So let's try to solve for a pizza that we don't know how big it is. And that way we can develop a formula. So I have some unknown theta, and I have some unknown radius. Well, the area of the entire pizza is pi r squared. And I'm going to times that by the percentage. The percentage is the part divided by the whole. So it's theta over 2 pi. What do you notice? The thetas or the pi's cancel, and I get r squared theta over 2. And that is the area of a sector, which is what we just had. Let me go back. Here is r squared. Here is theta, because that pi canceled. And then here's the divided by 2. So to find the area of the pizza, well, it doesn't matter. If you divide one of them by 2, you divide all of them by 2, essentially. Well, don't divide them each individually, just one of them. Yes, at the end, put divide 2 and you're good. So 8 squared times 5 pi over 18 divided by 2. So r squared times 5 pi over 18, and then divided by 2. Now, what is the unit going to be in this? Inches squared, square inches. Now, it makes no sense to leave the pi in a square inches problem. So when you're doing arc length, you have a pi answer and you have a non-pi answer. Well, because pi is a distance around the circle, we know, anyway. But in this case, it makes no sense to have pi inches squared. So we don't need the fraction version. All you need is the decimal version. So when you're dealing with arc length, you need 2 answers, a fraction and a decimal. When you're dealing with area, all you need is a decimal. So the area of that particular slice is 27.92, which is what we calculated the other way. So if you look at the first problem on the second page, theta is 3 pi over 4, and r is 15, so the area the formula is written right there. Area is 1/2 r squared theta, or r squared theta over 2. Same thing. So I'm just going to type it all in. 1/2 times 15 squared times 3 pi over 4. And you can type it in your calculator just like that. One half times 15 squared times 3 pi over 4. So the area of that sector is 265 centimeters squared. Yeah, that's the formula. 1/2 r squared theta. So all you have to do is type in r squared and theta. So the two formulas are really similar. S equals r theta and A equals 1/2 r squared theta. It's above, the pi button is above the exponent key, the caret. So it shouldn't take you too long to finish this worksheet. And then you have the rest of today and tomorrow to work on the practice test. Part 1 of the practice test will be on Monday. Part 1 of the test will be Monday. Part 2 of the test will be on Tuesday. Okay? And then we're going to go in and do a core test practice on Wednesday and then spring break. Well, the nice thing about this core test practice is you're not expected to know the answers, because all high school from secondary 2, actually secondary 1 all the way up to calculus, it's just one practice test. So there are going to be tons of questions on there you don't know the answers to. So we're going in there to practice so you can see how the buttons work, and you have to build certain things. And yes. Yes. I don't know where this rumor comes from. There's no senior English core test. But if you're in another core tested class, you have to take the core tests. So, sorry. But that's a rumor that people think all the time. Seniors don't have core tests. That's not true. There's no senior English core test. There's also no pre-calc or calc core test. What? I sure hope so. I've always put it on grades, so. It's not, actually. Okay, good luck.